suppose you're given the graph of a function and you are being asked to draw the graph in the polar coordinate system. So polar coordinate system uses angle and distance from the center to plot r comma theta, right? And to get some idea of what the corresponding graph would be, you should try to sample some points and see what you get. And the sample of points that you should get is these, at least the 4 points where you have 0, 90, 180, and then 270, and actually that's 5, and then 2 pi, which is 360. And another important points are these points where you have zeros. Okay, so I would say 1, 2, 3, 4, 5, 6, 7. If you plot these 7 points, you will kind of get an idea of what the graph will look like. Okay, so the first thing is when theta, this is theta and that's r. So when theta is 0, r is 3. What does that mean? That means this is theta equal to 0, right? So you go to that direction. How many steps? 3 steps. Okay, so you do 1, 2, 3, 3 steps right here, and that's where your first point is plotted. Okay. Next, you have pi over 2, which is 90 degrees. This is 90 degrees, right? Pi over 2 radians is 90 degrees. And for that, you go 1 step. So you go just 1 step. So that's the point. And then let's first do the 5 points, and then we'll think about what happens to these two. Okay. So at 180 degrees, pi radians is 180 degrees. So 180 degrees is this direction, but instead of going that way, you're going -1. R value is -1, so instead of going that way, you go this way. So that would be, okay, so if I number them, this is 1, 2, and 3. This would be 1, 2, and 3. Or I think numbers are confusing, so let's use A, B, C. This would be A, B, and C. Actually, now this will be A, B, and C. Okay, and then at 270 degrees, 270 degree direction is here, because you always measure from the positive x-axis, right? So 270 degrees is 3 times 90 degrees, so you go 1, 2, 3, so you're here, and in that direction you just go 1 step. Okay, and that will be D. Let's call that D. And then at 2 pi, that's again this direction, right? And there you goes 3 steps. So A will equal to E. So this point will be again E. So you go somehow here, and then come back here, and then come back here, and come back there. Okay. But along the way, there is actually these 2 additional points that we have to think about. This one is, see, this is 90 degrees, and that's 180 degrees. And the half of 90 and 180 will be 135, so it's slightly before. So let's just assume that this is 120 degrees. Okay, so if you have 120 degrees, this is the direction, 120 degree direction, and that's when the value of r becomes 0. And one important thing that you have to know is that when something hits 0, the direction that it hits the origin is tangent to the angle that you're given. So I don't know exactly what happens in between, but it's more likely like this, so that this curve will hit 0 exactly in this angle. Now same thing happens for here. This is more like 180 to 270. This, I would say, it's more like 240 degrees. There's some place here. So let's just say this is a 240 degrees, and then it either hits the origin or comes out of the origin while being tangent to these angles. So that's what it is. And now you can connect all these points and come up with the graph. Let's try. Just a minute. I need to change the color. More like that. And it hits 0. And then it hits B and then hits 0. And then it has to go from here to there, and while being still tangent to this. So because it's 0 being tangent to this, when it comes out it should still be tangent to this one. And then it will hit here, C, comes out, hits the origin, and does that. Okay, so that's what we call limaçon. So it's a limaçon with inner loop. Yeah. That's how you draw the graph.